Hey guys, today is our third lesson about shapes and attributes. So far we have reviewed a lot of vocabulary and we have talked about quadrilaterals, parallelograms, and rectangles. So today let's just get right into it with the rhombus. So the attributes of a rhombus. A rhombus is a quadrilateral, so it has four sides. And it also has four vertices. Remember, that's the corners, the points where the sides meet. It has two sets of parallel sides. So we're not talking about just two parallel sides. We're talking about the sets, meaning two pairs of parallel lines. So AB, that line AB is parallel to line DC. That would be one set. And line AD is parallel to line BC. That would be another set. So two sets of parallel sides. And the different thing about a rhombus that's different from what we talked about with other shapes is that it has four equal sides. All of our sides are equal length. And another term that you might see out and about if you read anything else that has to do with quadrilaterals and sorting and classifying them, sometimes that word equal would be replaced with congruent. So if you see the word for congruent sides, that means the same as equal sides, congruent and equal. You could see those interchangeably. But a rhombus has four equal sides. So AD, DC, CB, and BA, all four of these sides would be the same length, right? So if one of these side lengths was 3, this would be 3, this would be 3, and this would be 3, right? And then it would have a perimeter of, hopefully you remember how we did perimeter, we add all the sides, so the perimeter would be 12, right? Okay, all right, so that's a rhombus. So the next quadrilateral that we are going to talk about today is a square. So here we have a square, and the attributes of a square, it is a quadrilateral, so it has four sides and four vertices. A square has four right angles. So when we look at where our lines meet, these angles are 90 degrees, right? So this is 90 degrees, 90 degrees, 90 degrees, 90 degrees. Now that's different than the rhombus because the rhombus, none of these angles are 90 degrees. So pay attention to that difference between a square and a rhombus. All right, so four right angles with the square, two sets of parallel sides. In this case, we would have JK, that line, and ML. Those two lines are parallel. And JM and KL, those two lines are parallel. So you have two sets of parallel sides. Remember, parallel means that if I measure the distance between this line and this line, if I measured it here, and then I measured it again over here, it would be the same. The distance between the lines is the same no matter where I measured it. They're the same, they're equal distance apart from each other at any point. And if they kept on going and going and going, they would never cross. That's parallel lines. So it has two sets of parallel lines. And then a square also has four equal sides. So all of these sides are equal. So in this case, if JK, if that line had a length of 3, then KL would be 3, LM would be 3, and MJ would be 3, right? They would all be 3. So a rhombus and a square are very similar. Everything about them is the same except for the key difference of the angles, right? A square has these 90-degree angles, a rhombus does not. All right, so that is important difference. That is an important difference to pay attention to. And then the last quadrilateral that we are going to talk about is a trapezoid. All right, so a trapezoid, the attributes here are 4 sides, because it's a quadrilateral. It has 4 vertices, but it only has 1 set of parallel sides. That's it. So if we look at this trapezoid here, in this case, what are the parallel sides here? What's the set of parallel sides? So this side, SV, is that parallel to anything? No, right? Because SV, the line that's opposite of SV is TU, but if I kept going with TU, I'd go up, 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 and SV would go up, 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 and eventually those lines would cross. Those are not parallel lines. And if I kept going down this way, SV would go this way, TU would go this way, they would get farther and farther apart. Those are not parallel lines. ST and VU, these are your parallel lines, right? ST and VU. So this quadrilateral only has 1 set of parallel lines. Now, in this case, SV and TU happen to have these little hash marks on, which means they are congruent, or they're the same length. That's all that means, right? Remember that if you see shapes with these lines on them, it just means they're the same length. Doesn't mean that they are the same. It doesn't mean that they're parallel. So in this case, this line and this line are parallel lines because this is a trapezoid. And a lot of times for a trapezoid, when you see it drawn, this is kind of the traditional shape that you'll see. But this is a trapezoid here as well. This figure is a trapezoid. So this figure has 4 sides. It has the 4 vertices. And it does have 1 set of parallel lines. So which lines here are parallel? Hopefully you realized that this line EH is parallel with FG, right? Those 2 lines are parallel. This line at EF, if I kept going with this line, it would come down this way and eventually it would cross with this line, right? These lines are not parallel. So it does just have 1 set of parallel lines. And with this shape, none of the sides are the same length, right? There's none of these little hash marks because none of the lines are congruent. None of the lines have the same length, and that's okay. A trapezoid, if we look at our attributes, it doesn't say anything about that. It doesn't have to have lines that are the same length to still be considered a trapezoid. All it has to have is 4 sides, 4 vertices, and 1 set of parallel sides. Okay? All right, so for wrapping up, let's think about a couple of questions to kind of think about our attributes and how they work together. Is a square also a parallelogram? Think about that. You can pause it if you want. Is a square also a parallelogram? So think about a parallelogram from yesterday. So yes, a square is a parallelogram. If you remember yesterday, we said that a parallelogram, to be a parallelogram, you must have 2 sets of parallel sides and 2 sets of equal sides. And a square definitely has that. Here is the slide we looked at for parallelogram, right? A parallelogram has 4 sides, 4 vertices, 2 sets of parallel sides, 2 sets of equal sides. Well, 2 sets of parallel sides, 2 sets of equal sides, that still falls into this 4 equal sides, same thing. So a square fits all the requirements of a parallelogram. So a square is also a parallelogram. All right, what about this one? Is a square also a rhombus? Could we say that a square is also a rhombus? Yes, this is always true as well, because to be a rhombus, a shape must have 4 equal sides and 2 sets of parallel sides, which all squares have. I mean, a little boo-boo, I should have squares there. Okay, good. So yes, it's always true, because to be a rhombus, you have to have 4 equal sides, and a square has 4 equal sides. And a rhombus must have 2 sets of parallel sides, and squares have 2 sets of parallel sides. So a square can also be called a rhombus. So hopefully in your mind, you're kind of seeing how these attributes, some figures, some shapes share attributes, and some shapes, even though we look at a square and we say, oh, well, that's a square, well, it can be called other things, right? Okay, bye for now.